All right, thanks everybody. My name is Jeff Mendoza, and I'm here today to talk about what makes a project critical. Quickly an introduction on myself. I'm a software engineer at Kusari. I'm also a maintainer on the Guac project, leader of the All-Star project, and I'm here today to talk about the Securing Critical Projects Working Group, where I am a co-chair. All right, so everybody's probably pretty familiar with this XKCD. There's a lot of ways to solve this, and one of the ways that we think, not going to solve everything, but that we think is going to help this problem and the kind of core problem statement of the working group is that we think that that these projects can be served by more resources. Hopefully that's not very controversial to say. We need to find the projects, one, but also figure out a way to get the resources to those projects. Resources can be lots of different things: money, credits, working hours, things like that. We've distilled that kind of overall guidance into a mission and vision for our working group. So here's, again, the text. Not going to get deep into it, but at a high level, as you can see, it is, these projects are critical. They don't have all of the support that they need. And so the vision here for the working group is that if you are an entity and you think, hey, open source is important to my group, my organization, I want to set resources aside, I want to give resources to open source to improve the security of open source, that is easy to do, and you can do that in an effective and efficient way. So how are we going to do that? The first thing that we needed to do was we needed to decide which projects are critical, because those are the ones that we need to go help. Now, taking a step back to the mission and vision, we're looking to serve underserved critical projects. But firstly, we decided to find critical projects, not necessarily ones that are underserved. In doing that, we came up with a definition of critical. And this is kind of interesting because the working group has gone through this process actually twice now. We've done a lot of discussion on which projects are critical, which ones aren't. And this definition kind of came up from all of the discussions on whether a project is critical or not. We didn't write this down first. We kind of went through the process and organically came up with the definition. And this text here is pulled from the introductory text of this set of critical projects. And it says here that vulnerabilities, whether intentional, unintentional, or malicious, could cause widespread problems, both in significance of breadth. So problems is also known as impact. What would the impact be of a vulnerability in the project? And the criticality includes both significance and breadth. So you want to have some amount of both, a medium amount of both, or a lot of one and a little bit of the other. But you can't have none of one for a project to be critical. And then another thing that gets conflated with criticality often is frequency or likelihood. So here I want to call out that this is not something that is part of being critical or not. Frequency or likelihood is basically the probability that a vulnerability is going to happen in a project. Some factors that are included in this probability are things like the size of the project, how much support it has, how many eyes are on the project, how many people are working on it, does it have the backing of a big organization, what technology does it use a memory-safe language or not, and other security posture things like what the OpenSSF scorecard project scores. All of that goes into frequency likelihood and is not a part of criticality. I do want to call out another thing that people look at here is the frequency of past vulnerabilities. And again, that's probably not a good metric, but that would be in frequency or likelihood and not part of criticality. So here's what the working group did to create the set of critical projects. We took 2 steps. It was pretty straightforward. First, we found projects, and then we evaluated whether or not they were critical. So what did we look at to find to discover all the projects in the world to decide if they're critical or not? We used some algorithms. Criticality score is one. a project under the working group that uses an algorithm to decide whether a project is critical or not. We use that to kind of discover projects. We used it a little bit in evaluation later, but primarily for discovery. We just looked at well-known projects. We looked at top corporate-backed open source, top foundation open source, and included all those in the list. And then since we've been doing this for a little while, we have had a lot of good community suggestions on, hey, this should be in the list, this should be on, you should take a look at this project, and those sorts of things. So once we had all the projects that we wanted to evaluate, we moved on to the evaluation. So again, when we're looking at criticality, we're looking at both breadth and significance. So here's kind of I would say the meat of this discussion here is how do you decide if something is critical? So on the breadth side, we want to find evidence that, of course, it's used widely. So easy way to do that is look at some statistics. The criticality score is another one that we used. That one shows kind of how active the project is. Does it have a lot of commits? Does it have a lot of contributors? The Harvard Census research was a good data source for us. If you want to learn more about that, go to our working group page. We have links to that. So all of those things would show, hey, this project is used widely. Then we looked at other things like download counts. If it's a package on a package repository, those might be available. If it has a Docker image, those download counts are available. On some classes of things like databases, we thought, okay, well, what are like the top 5 or top 10 databases, and let's just kind of draw the line there and say that this type of software is in this group, and we're going to figure out which ones the most used ones are. And then, anything that was just completely apparent that this is widely used, like if it's the Ruby language or any kind of very large language, top 10, the language, the package manager, the compiler, whatever part goes in that's the open source project to that, then it's pretty obvious that it has a wide breadth of use. But this isn't the only thing, again, because some, you can look at the top NPM packages and say, hey, these have a bajillion downloads and they're used in every web page, but maybe they don't do something very significant in the actual program or project that it's included in. So we had to look at significance and again combine that with the breadth. So one interesting is, where is this piece of software used in the stack of like a typical critical system? So this borders on likelihood because we're kind of guessing if there were vulnerability in this project, would it be exploitable? But it's different because we're not just looking at the probability or the support of the project. We're looking at where does it fit in the technical stack-wise. So if it's a package or project that is included in a system that's always exposed to the network, that would mean it's more critical because it's more likely to be exploited. Versus a basic library that's deep down and data, user input usually doesn't get down to that level, then it wouldn't be as critical. Same thing for security. If it's something that's used for authorization or authentication, then if it has a vulnerability, then it's typically going to give somebody more access than that they intended to have access to. And then we didn't do this a lot, but the kind of use came up a bit. So if it's a package that's used mostly in personal blogs, I'm not going to say WordPress because that's used for a lot more than that, but that kind of realm, then maybe it's not as critical as something that's often used in more big complex systems from critical infrastructure. Continuing on significance, what is the access that this typically has in a system? So if you imagine like a standalone monitoring system, it's pulling in data from all the different services in a system, but it might not have any actual access to like the database to read critical information or write access to other parts of your infrastructure. Whereas that same project might have a monitoring library that's built into every single one of your services, which would, if it had a vulnerability, then every single one of your services would have a vulnerability. Similar kind of thing to consider here is like the static site generator versus the HB server. Static site generator is something you run in your build or something outside of your main active system, versus obviously an HTTP server would be running all the time and serving data to everybody. All right. So quick talk here, but just wanted to wrap up everything. We built this list of critical projects. We use all these considerations to decide, what is critical, what is not. This was a human process. We used those statistics, those criticality scores, to find or evaluate the projects, but we used our human working group to get together and weigh the pros and cons or weigh the different weights of each part and decide what's critical and what's not. And the way that the bar that we set, because everything, you can get an idea of the breadth or significance of something, but you have to set a bar somewhere to decide how long you want the list to actually be. We started with a goal of about 100, but that grew a bit more, but we still want to kind of keep the list maintainable. So around in the hundreds is the bar that we set. If we set a lower bar, we'd end up with 10,000 projects that we decided are critical, and we wouldn't be able to go through them all and have this kind of discussion. So next steps, back to the working group's mission and vision. We need to turn this list into something that people can use to, again, get those resources to these projects. So we need to find a way to filter the projects, so somebody can say, hey, I want to donate to the top Python projects, and say and add that filter and see that list. And then we need more information on what those projects can actually use. So this is what we're doing in the working group right now. If that sounds exciting to you, please join us. How can you contribute? We have our meetings on the public calendar. We're the Securing Critical Projects Working Group on Slack, and our GitHub page is here. Also, head to our GitHub page if you want to read more details on the whole process as well. That's it.